Welcome, Sandra. The floor is yours.
Thank you very much. Thank you for having me. Yeah, so I decided to talk about hate speech detection because this is a really important topic. Hate speech is becoming more and more prevalent in social media everywhere. Europe has laws saying that social media platform providers have to take it down. But there's a lot of problems with this approach. I am going to focus mostly on the data situation today. We've done work on how to address hate speech computationally, but the more we do in terms of machine learning, the more we realize how important the data are. And there's a lot of unanswered questions there that need to be answered, I think, before we can make real progress in that area. So let's get going, if I can get this started. So let's start by defining hate speech. Hate speech is, we'll see a couple of terms, but before we do that, it has a lot of different names that we're using. Something like abusive language detection. If you ask me what the difference is, not really sure. I think abusive language is probably more general, but then there's also some people who are saying abusive language is more specific. You can also talk about toxicity detection, cyberbullying, flame detection, and so on and so forth. I think all of these are facets, and I'm grouping everything under abusive language detection. Since hate speech has become the prevalent term, this is what I'm going to use in my talk today. All right, so let's start with examples. I normally ask people what they think about that. So if you're online, please give me thumbs up if you think an example is hate speech. I'm starting with the first one. The Donald does not like people who disagree with him, even babies. What do you think? Is that hate speech or not? Okay, thank you, Yanis. Yanis is saying no. Okay, next one. Dude, it was a Philippine flagged merchant vessel. That's all you need to know. What do you think? Okay, I get 2, 3 yeses. So I don't see all the other people. The next one is the really idiotic observation is new immigrants can go anywhere they choose as we are too nice to demand they go where needed and we want them to go. So much for chance credibility. What do you think? Is that hate speech? No? Okay. Next one. If Amazon moves here, maybe they could take over RTD because these idiots can't seem to run a train. All right. I'm gonna skip the next two. So these are all examples taken from one publicly available data set. It's a very large one, and this is the one that we have been mostly working with. And if we're looking at the annotations, the ones shown in red were marked in as hate speech, the others were not. And we've seen that some people who are visible here actually tend to disagree on some of those. I do disagree on some of those as well. Maybe not all of them, but okay. My personal favorites are, how is the new dictator working out for you? And dumb shit, left shit in toilet, now he's up shit creek. And I'm actually teaching a course on hate speech detection, and it's fun to make my students say all these words in class. So for those two examples, the first one surprisingly is not hate speech. The second one is. At least that's what it's annotated as. All right, so let's move on to this definitions. This is the first thing that I normally do when I start working on a project. I want to know what other people think we're talking about. So the Encyclopedia of the American Constitution says, I'm going to mark the important part. Hate speech is speech that attacks a person or group on the basis of attributes such as race, religion, ethnic origin, national origin, sex, disability, sexual orientation, or gender identity. So the important part here is that there has to be an attack. And the second important part is that it's based on specific attributes. They say such as, so there can be more, but we're not super clear on what the other attributes are. Facebook has a similar definition. They want a direct attack. and they say protected characteristics. So race, ethnicity, national origin, religious affiliation, sexual orientation, caste, sex, gender identity, and serious disease or disability. We also provide some protection for immigrant status. And I think that that's an interesting story here, because all the other protected characteristics are protected by the law in the US, at least as far as I know. And then it turns out that there was a lot of hate against immigrants at some point. And then they were faced with the problem that a lot of people left Facebook because there was so much hate speech on there. And this is why they added immigration status as kind of a semi-protected category. Unfortunately, that still means that if you do not fall into any of those categories, you can still get directly attacked, and Facebook doesn't really care. Facebook goes on to say, we define attack as a violent or dehumanizing speech, statements of inferiority, or calls for exclusion or segregation. So they're at least a little bit more specific about what they mean by direct attack. Twitter says, hate speech is, or hateful conduct is, you may not provoke violence against or direct attack or threaten other people on the basis of, again, race, ethnicity, national origin, sexual orientation. That should look familiar by now. So here, the violence is new, but then we also have the direct attacks. Okay, so what about humor? In 2013, Facebook stated, we do, however, allow clear attempts at humor or satire that might otherwise be considered a possible threat or attack. This includes content that many people may find to be in bad taste. Examples are jokes, stand-up comedy, popular song lyrics, and so on and so forth. They took that down, and I think there's a very good reason for them to take that down, because sexist jokes are still sexist jokes, and a lot of them should not be uttered. And it doesn't matter whether it's sexist or racist or whatever. I think there has to be a boundary. Where that boundary is a very difficult question, and nobody wants to talk about this. So what about non-protected groups? So if somebody is making direct attacks or serious fun of you because of your age, because of your immigrant status, because of other things, I mean, is it fair if somebody cannot be attacked because of their, I don't know, sexual orientation, but they can be attacked because of their age or because they're, I don't know, boys or girls or whatever? I don't know. I think just having the legally protected categories may not be enough. The other question is, what constitutes an attack or violence? Where do we draw the line? So we've seen examples, and a lot of times it's very hard to say if this is actually attacking people or if it's just, I don't know, making fun of them or stating an opinion. And I mean, you can't forbid people to state opinions, right? We have freedom of expression. So it is a very difficult line to draw. And then the next question that nobody seems to talk about is who decides? And how many people does it require to call a text hate speech? I mean, we can't say it has to be the majority, right? Because a lot of times people in minority groups are being attacked. So if the majority has to say this is hate speech, then we have a problem because that does not protect the minority groups. But then if we go down to a single person, so anytime somebody says this is hate speech, somebody has to take it down, then I don't think there will be a whole lot left on social media. So finding a good balance between that is a difficult thing, and I think we need to talk about this, except nobody does. So that puts a lot of pressure on content moderators, for example, or on social media platforms, because they have to decide where they draw the line. And that may not be the same across all the different platforms. The next question is, does the target need to be a person? What if you insult someone's work? And this is a discussion that we had in our project, in the annotation project. I don't know if Holly is here, but we've had long discussions about that, because yes, if I say somebody is an idiot, that is hate speech, right? But if I say somebody created a very idiotic building, or that building is idiotic, or that, I don't know, that system is idiotic. Or if you talk about a state, like Germany is stupid, or the US is stupid, or whatever, is that still hate speech? And that's a very difficult line to draw, because I mean, I should be able to say that a building looks stupid, or it is stupid, or the construction is stupid, or whatever. But in a way, indirectly, you're still insulting the person who's behind that, right? And that may be clearer if you talk about a country. Because if you're talking about, I don't know, the country is racist or whatever, then you're talking about the people in the country. If you're talking about the country has stupid laws, then you're talking about the government, and these are people. So where are we drawing the line between are we talking about people, or are we not talking about people? If you expect me to answer those questions in my talk today, I'm sorry, I have to disappoint you, because I don't really have those answers. But I think that these are important questions that have to be talked about. I'm doing hate speech detection. So the easy way out would be, I'm just creating machine learning algorithms. I'm creating better approaches that do hate speech detection. But then I have to work with the data. So I'm focusing on the data for now. And data sets are, there's plenty of those. So some of the more well-known ones are the ones by Wasim and Hovey, or by Wasim. There's two different ones. Then there's the Davidson one, or hate-base, sorry. There's Stormfront, OLID, Solid, Kaggle, and Hadevel. Sorry, I keep calling it Hadevel. I don't think that's a good acronym. These are data sets that everybody uses. And if you look into those, I showed you examples from one of the Kaggle competitions. And you can look at all of those, and you can complain about the annotation quality, because there will always be examples that you don't agree with. I think annotator bashing is a sport that a lot of people do. And I don't think it's fair. Annotating these posts is really, really, really difficult. And it's very easy to say, I don't agree with this one, or I don't agree with that one. Doing a better job is much harder. And we don't really know how to do this. So when I'm criticizing data sets, I'm trying to do this carefully, because I know that a lot of work went into this, and a lot of times it was hard work. And just because I don't agree with some of the decisions doesn't make it a bad data set. Some data sets are not good, on the other hand, because a lot of times people haven't thought things through before they started collecting data. So we have to talk about that. Okay, before we do that, we also have to talk a little bit about machine learning. And since I'm assuming that there's a lot of people on the call who don't have a whole lot of machine learning experience, I want to talk a little bit about what that is, because we need to know what that is and how it works, and especially how we evaluate. And normally when I talk about machine learning, I start with cats and dogs, or pictures of cats and dogs. Because one of the tasks that a machine learner has to solve at some point, this is one of the standard data sets that people use, is classifying pictures into, is this a cat or a dog? And if I ask you, you should be able to tell me that this is a dog, the second one is a cat, the third one is a dog, and then we have another cat, a dog, a cat, a dog, and then, oh, wait, we have two cats. This should still be classified as cat. So I've taken those from a fairly generic data set that people use for machine learning experiments. So this picture actually should also be classified as cat. But then if we think about how do we know that like the second one is a cat, and the one below that is a dog. And we talked about that with my students in class, and one of the ways of explaining that would be try to explain this to a blind person. How do they recognize a dog and a cat if they can't hear them? I mean, yes, the noise that they make is very different, so we should be able to distinguish them. But if we don't have that, if we only have the visuals, and the other person doesn't have the visuals, then it's very difficult, right? Maybe dogs have rounder eyes, cats have Cat's eyes are not that round. Cat's ears are different. The dog's nose may be longer. All of this are things that my students came up with, but this is very hard to tell a computer, right? So basically what we're doing when we're telling the computer is we're breaking the pictures down into pixels. So we're splitting up this picture into 1 dot, 2 dots, 3, 4, 5, 6, 7, 8, and 9, 10. And then we tell the computer what the color of this one little pixel is. And then we're giving the computer a lot of examples in the hope that the computer will learn from the examples and the correct answers. So we're telling the computer, this is a dog, this is a cat, this is a dog, this is a cat, and so on and so forth, that it can come up with generalizations across the different pictures. So if you have these dark round areas in the picture, that may be dog eyes. If you have the more greenish areas, that may be a cat eye. And different contours of noses. And for that, it's really important that the MLs look into different directions, because otherwise you would only recognize them if they look straight at you. So this is how my computer deals with the problem. It will probably have a problem with the cat dog. I learned about this from my students. I didn't know that the cartoon existed, but that would be a real challenge for my computer, right? Okay, so machine learning basically means that I'm not giving my computer explicit rules. I'm not telling it, watch out for the shape of the eyes, because how would it know where the eyes are in the picture, right? Instead, I'm giving it a whole lot of examples, plus the correct answers, and then I let it extract regularities from the data, from the examples. And computers are much better at finding regularities than we are, especially when you have a large data set, right? Our attention span is pretty limited. The computer's attention span is not. So it's much better at sifting through a lot of data and then trying to find regularities among that. If we do that from label data, we talk about supervised learning, and this is what I'm going to focus on for my talk today. But we can also have unlabeled data, and then it's called unsupervised learning. In that case, the computer would, going back, only get the pictures and no labels, and then it would have to figure out which ones of those are similar groups of pictures and how to separate them out. Okay, evaluation. Since we're talking about evaluation of machine learning algorithms, this is important. The terms that you need to be familiar with are gold standard. This is the data against which my machine learning program is evaluated. And these are the correct answers. So what the humans decide is the correct answer, that's the correct answer. If the human is wrong, then it still counts as the correct answer. And normally we get one big data set and we split it up into training data and test data. So the training data is the one where that the computer gets to make to draw the regularities from, and then we're testing on the test set to figure out how well it does on data that it hasn't seen during training. We normally report accuracy, so that is the percentage of correctly classified instances from the test set. So if I have 100 examples in my test set and I get 97 right, then my accuracy is 97%. We often also talk about recall and precision. Recall is the percentage of the items in the gold standard that were found by the machine learner correctly. And precision is the other side of the coin, the percentage of the items selected by the machine learning program that are correct. Let me give you an example. So I have, in my gold standard, I have 50 hate and 50 non-hate examples. My machine learner has 27 hate and 73 non-hate. So you can clearly tell that some of them are wrong. If we assume that 25 of the 27 hate examples of the machine learner are correct and 46 of the non-hate are correct, then my accuracy is 25 plus 60, sorry, 46. Did I calculate that correctly? Sorry, I changed my numbers around, so that is incorrect. So it's 25 plus 46, so that number is wrong. Sorry about that. If I calculate precision, that's the more important one. I take the 25 over the 27 that the machine learner called hate speech. And that is 92.6%. So my precision if the machine learner is saying hate speech, the precision is 92, that's really good. But the recall is only 25 out of 50, so out of the ones that it should have found, and that's 50%. We often talk about the F-score, which is the harmonic mean of those two numbers. And since I calculated my precision wrong, that number is also wrong, sorry about that. But we normally, I've given you the formula here. The harmonic mean means it's, if the numbers are very far apart, the F-score is closer to the lower number. I have another example. Hopefully that one was correct. Yep, that looks better. So if I have 10 gold hate speech examples and 90 non-hate speech examples, and my machine learner calls 4 of them hate and 96 of them non-hate, 2 of them are correct and 88 are non-correct, and my accuracy is 90%. Precision, 2 out of 4 is 50%. Recall, 2 out of 10, we're looking at hate here, is 20%, and then the F-score for hate would be 28%. You can also do the same for non-hate, and then you can average over the two, and that gives you an F-score. That is normally a better metric, especially if you can separately look at precision and recall, because accuracy is very misleading, because we will have a lot of non-hate and very little hate in the data. And in that case, accuracy is not a good metric. Okay, I'm hoping that makes a little bit of sense, so keep that in mind when I'm talking about results. Okay, let's talk about data issues. Data issues that I'm seeing are the sampling strategy, annotator biases, and annotator consistency. And we'll look at all of those in a row. Okay, so sampling strategies. We have to start by figuring out that my machine learner is only as good as its training data. So if I'm training it on, I don't know, Shakespeare poems, it will not be very good on social media data. If I train it on Twitter data and then test it on Reddit data, it will also not be very good, because Twitter data and Reddit data is very different for the machine learner. So the more realistic the training data are in terms of what it gets as test data, the better the machine learner is. So if I wanted to come up with a machine learner for hate speech on Twitter, the best thing for me to do would be to sample, I don't know, a day of Twitter feed or an hour of Twitter feed, depending on how much I want. But unfortunately, if I do that, there is not a whole lot of hate speech in there. I think the general estimations are 3% or less. It's probably less. And that means there's not enough hate speech in there for my machine learner to pick up. Because if you look at accuracy, if it classifies everything as non-hate, it gets most of them right? It only makes 3 out of 100 examples wrong. And that's not a good thing. So we have to boost the hate speech in my data set. Otherwise, the machine learner doesn't have any way of finding them. And there's normally 2 different ways of doing that. One of them is randomly upsampling hate speech. And there's different ways of doing that. So that just means I'm trying to find more hate speech and push it into my training set. Another way of going about that is saying, I'm not trying to randomly do this, but I'm going for topics that people talk about where I know that there's a lot of hate happening. So if people talk about soccer, if people talk about football, if they talk about religion, there is a lot of hate speech there. We know that. So if we look for hashtags, for example, on Twitter, that are related to football, to soccer, to Islam, to any other religion, you will get a lot of hate. And you don't have the problem that, I mean, I could also look for, I don't know, the N-word, for example. That would give me a lot of hate, but it would not give me a lot of non-hates. And it would bias me, or it would bias my data set towards the easy cases where somebody uses a slur. Don't want that. So topic-based may be better, but then it also means that if my data set contains soccer, football, and Islam, then it will be very good on predicting hate in these areas, but it will not be good at predicting hate in other topics. Okay, so we have to talk about, we have to worry about how do we find the hate speech so that we can put it in our data set. For randomly upsampling, I think one of the dumbest approaches that you can use is semi-supervised. So you sit down, you annotate a few examples, and then give them to the machine learner, train the machine learner on very few examples. That means it's a very bad machine learner. Run that on more data, and everything that's called hate speech in the more data will be added to the training data. That means you're really getting the easy examples, like the slurs, the N word, the F word, the B word, or whatever. That's what's going to get in your data set. But the harder examples, you will see this later on in my talk. One of my favorite examples is, who would want to read a book by a woman? That's very implicit hate. It's hate, but you can't tag it onto any specific word in that example. Those you will not get that way. So a better way would be potentially to upsample users who are blocked for abuse. So if a user on Twitter, for example, is known to be abusive, then if you take more of that user's tweets, you should get more hate in there. But then if you're not careful, you would get a lot of tweets from very few users. So in a way, you could model those users, but not anyone else. You also don't want to do that. So no matter what way we choose, there's always downsides, and you have to be very careful in order to get this right. And you introduce bias this way, and we have to be aware of that. Okay, so let's look at a couple of studies where people have looked into this. I'm starting with a paper by Michael Wiegand et al. From 2019. They looked at two types of sampling bias. So they said whether you randomly upsample somehow, so if you take more users who have been abusive and add those tweets to the data set, or whether you use topics like football, soccer, or Islam, or whatever in order to sample your tweets. They used 6 existing data sets, and 3 of them were randomly sampled or randomly boosted, and 3 of them were topic-based boosted. And then we ran the same machine learner fast text on all of those data sets. This is what they found. They looked at what percentage of hate speech was in the data sets. So what the annotators decided was the percentage of hate speech. And you can see that that varies quite a bit from about 10% to almost 60%. Here is what the machine learner did. So how well the machine learner worked. And again, this is the F score. So this is the harmonic mean between precision and recall. And you can see that for randomly sampled data, it's actually pretty good. For the ones that were topic sampled, the task looks a whole lot harder. So they get lower results in that. They also looked at how much explicit hate is in there. Explicit means you have, for example, slurs in there, you have the N word in there, you have the F word in there, or so on and so forth. And again, we can see that the randomly sampled ones seem to have more of the explicit hate, so the easy kind of hate to find, and the topic sampled ones seem to have more of the implicit hate, something like who would want to read a book by a woman, and things like that. Okay, so there are significant differences between the data sets. Random sampling creates easier data sets. The percentage of hate posts in randomly sampled data is smaller, and topic sampling potentially results in topic machine learners. So they're very good at finding hate in soccer, in football discussions, in Islam discussions, or I don't know, you can also talk about Catholicism or whatever. It's very good at finding those, but it's not good at finding hate speech in other topics. But it's also hard to say because they use different data sets, right? So it does not necessarily have to be the sampling strategies that these people used, but it could be something else that's in the data set because they're different. Going back to this, they have different sources, for example. So it's very different language that is in there, and that may make a difference. The way they sampled may make a difference. So I sat down with an undergrad student of mine, and we repeated those experiments. But we said, let's take one big data set. So we actually took the 2 Kaggle competitions because you had several millions of tweets. Sorry, they were not tweets, they were posts. And we said, if we take this one big data set, then we can apply both sampling strategies to the same data set, which gives us a more controlled experiment to see if there's actually differences in the sampling or if the differences come more from the underlying data sources. So whether it's Wikipedia or Twitter or Facebook or whatever. Okay, so that's what we did. And this is what we found. So we did random sampling and we did topic sampling. And we found that if you did random sampling, we had more abuse in the data set than if we did topic-based sampling. And that also shows, it also shows that we're doing better on the random sampling than on the topic sampling. But there is no direct correlation between random sampling and topic sampling. So we get more abuse, but we actually repeated those experiments a couple of times. So we sampled separately a couple of times, and we get very different numbers depending on how we sampled. So there is no direct correlation between how you sample, whether it's random sampling or topic sampling. Just repeating those gives you different numbers. The abusive class in topic sampling is considerably harder to detect. That is a consistent trend. And the differences between sampling strategies are much smaller than in Wiegand's experiments. So we assume the differences come from the underlying data sources and not from the way we sample. Okay, so what does that mean? So how do we make sure that we're evaluating my machine learner properly? Because it looks like depending on what data set we use, we get different results, right? And people have suggested a solution, namely evaluate across data sets. So since we have this long list of data sets, why don't we take one, train on it, and then we can test on all the others? And people have done that. So this is one of the papers that did that. And you can see that they get very, very, very different results. The darker the results, the higher they are. The lighter the color is, the lower the results are. And we go from, I think, 2.7 up to, I see an 89 or something. There's a 90 here, 92. So there's huge differences. Is that the way to go? I don't really think so, because as I said, my machine learner is best on the data. If the test data is similar to the training data. And if you're training on Twitter and testing on Facebook, then that's just not the case. But you don't know where the differences come from. You don't know where the differences are in the text types, whether it's Twitter, if it's tweets or Facebook posts, or it could be blogs, or it could be something completely different, or whether it's differences in the annotations, in the annotation guidelines, or things like that. And all of these differences are potentially in there, and we have no idea where these differences in the results come from. So I don't think testing on one data set and training on one data set, testing on the other data set is a good way to go. Okay. Moving over to annotation issues. So it turns out that our data sets tend to be biased. Which is, you may have heard about the large language models, that they have a lot of biases in them. They tend to be very sexist. They tend to be racist. They tend to have a lot of biases. And we're working on debiasing them, but that works best if you know what biases are in there. The same holds for the data sets that we're talking about with regard to hate speech. So what kind of biases are in there that we need to control for? There may be biases in terms of race and ethnicity. There may be biases in terms of dialect, gender, age, ableism, political leanings, and there may be a whole lot more than I'm not even thinking about. I don't know what the list is. But if I don't know what biases there are, then it's very hard for me to delete them from the data set. All right. people have looked into that. So people have looked into annotator bias, for example. And there's one study by Sapp et al., which investigated racial bias in annotators with regard to African American English. So they wanted to know if a tweet is in African American English, is it considered hate more often by the annotators than if it is some white American dialect? And the reason for that is that African American English uses a lot of words that are considered toxic in standard varieties of English, but not in African American English. So for African American English, the meaning is different. But then it would be unfair if we're deleting hate speech, it would be unfair to delete hate speech if it's African American English, if the African American community doesn't consider it hate speech, right? That would be racial profiling in a way. So they checked the false positive rates in the machine learner output. False positive means the machine learner said it's hate speech, but it's actually not. They used 2 different data sets. And this is what they found. I'm showing you a lot of numbers. So they split the test data up into African American English and white English. And they looked at the accuracies. In the one data set, the categories were none, offense, and hate. In the other data set, we had none, abuse, and hate. Okay, and if you look at those numbers, we get more false positives in offense in the Davidson set for the African American language. We also get more false positives in abuse and hate in the Fountain data set. So this is concerning. So my machine learner is learning from the annotators a bias against African American language, right? And we should get rid of that. So, but how do we do that? How do we have to train our annotators to make sure that they get rid of that bias? And they did a study on that. And they had 3 conditions: the control. These annotators were not given any additional information. They had one set of annotators who were dialect primed. So they were given the dialect info of the tweet. So they were told that this is a tweet and this tweet is written in white English, or this was written in African American English. They had a 3rd condition where the annotators were given more information. It's called race priming, where the annotators were instructed to consider the dialect info as indicator of race, and be aware of the race. Okay, this is what they found. So they actually had 2 different conditions. They asked whether a tweet was offensive to anyone or offensive to the specific annotator. And again, we had 3 conditions. We had the control, the dialect, and the race condition. So race priming, sorry. And you can see that the numbers are very, very different. So if for the control, 42% of the posts were considered hate. For dialect priming, only 33, and for race priming, only 30% of those were. So these are significant differences, and that's going in the right direction. So we get a lot less that are considered hate. We also see that it makes a difference whether you ask about everybody else or if you asked about, is it offensive to you? I'm still pondering what that means. I'm not sure what we should ask the annotators to do. I'm actually following up on this in a study with my undergrads. I have a lot of undergrads this semester, so we're conducting a study to see what the differences are. Okay, moving on to work that I did with Holly Lopez and a couple of other people. So we sat down and we started talking about, we looked at the data set, and I was mostly interested in annotating tweets or distinguishing tweets between explicit hate and implicit hate. And normally what computational linguists do is they come up with a list of hate speech words. And if one of the hate words is in a hate post, then it's explicit, and otherwise it's implicit. And I wanted to know how well it works, actually, because it depends on your hate list, right? So I asked Holly and another student to sit down and annotate some tweets that were considered hate, based on whether they're explicit and implicit. And they got back to me and said, well, we can't do that. And I asked you, why? Well, a lot of the ones that we looked at don't look like hate speech to us. So this showed us that a lot of the annotations, annotators have a tendency to misclassify profanity or abuse against non-persons as hate speech. So if you have a post, I do love Yatai Maru's ramen. It's a perfect food for Portland's long winter, and PDX does kick a little ass. Ass is profanity, but you can't really call it hate speech, right? This is actually a very positive tweet. Or sorry to have to do this, but just to see if profanity filtering is enabled, fuck. Again, we have profanity, but it's not really hate speech. And then we have an example, took this as an opportunity to check back in on the yard, and the floor plans are finally up and they are atrocious. So this is the thing that I mentioned before. If you talk about a building, is it still hate? If you talked about a person, yes, of course it would be hate. But if it's a building, we argued about that and we decided, no, not really. So we came up with a new annotation scheme where we focused on splitting up the non-hate categories to make annotators more aware of those differences. So we had explicit hate and implicit hate because that was what we were interested in. So for implicit, we had Trump loves his uneducated voters. It sounds like you know a few yourself. Self-abuse is one of the categories that we came up with. That's not. I mean, you should be able to say anything about yourself. I mean, this is a gray area, right? You may want to take that down because the self picture that people are getting may be helpful as well. But it's not necessarily hate. Okay, we also have irony. Something like, well, shit, they drafted a guide. We should all be good now. Ooh, what a relief. That's ironic, but it's not hate. Colloquial profanity. DARPA, the subdivision of Defense Department in charge of devising really scary shit that's never been seen on Earth before, aka the images of the internet. The really scary shit, that's profanity, but it's not hate speech. And then we had meta comments, also sometimes called counter speech, so the slurs against Hillary should be stopped. It's time to confront them at every appearance. We all have seen that to ignore them as too ridiculous isn't effective. Saddam had WMDs, Saddam caused 9/11, Obama is a Muslim, and so on and so forth. So this is speaking out against hate speech, and we should not confuse that with hate speech. Argumentative, this is something that my students tend to struggle with a lot. Great story. Frankie tried to expose corruption and ends up murdered. Problematic interrogation tactics by OSP. Can't wait for more info on this case and final proof of the real murderer if this man is not responsible. And so on and so forth. So there's a lot of controversy going on and people have very frank opinions, right? But that doesn't make it hate speech. And my students find it very difficult to distinguish between those two. So they have a tendency to, anytime they're slightly uncomfortable by something, by controversy, they call it hate speech. And then we have the non-abusive category. So we sampled 10,000 posts from Kaggle, re-annotated the posts, the abusive posts with a new annotation scheme, and this is what we found. We had about 1,100 explicit hate speech, we had 400 implicit, and we had 7 self-abuse. We decided to count it as abuse because we don't really propagate this kind of thing on social media. So we had about 1,500 abuse. All the others were originally by the annotators classified as abuse, and we decided they're not. So we had a lot of argumentative ones. We had a lot of meta comments, and we had a few colloquial profanity. We had a few irony, and we had some really, really non-abusive ones. Whew. All of those originally were hate speech. So we also wanted to know what that does to my machine learner. So we replaced the annotations for the originally abusive posts. So only the 15, how many were there? 1,800 were we changed out of the 10,000, and then trained and tested the machine learner again on the original and the new annotations. If we do this, this is what happens. So we have the expert annotations. These were the ones that we did, and we had the crowdsourced ones that were in the original data set. If you look at the numbers, the F score is lower by almost 8.5%. That's a decent amount. That means when we do this, when we classify a lot of the examples as non-hate because they have offense and so on and so forth, then the problem gets a lot harder. And the F for abusive class is lower by almost 20%. So it gets a lot harder to find the abusive language. Okay, if we train our students, what happens? Still the same thing. So we haven't gotten to the end of this yet. My students still, if something makes them uncomfortable, they still call it abuse. Okay. I think I'm gonna skip that in the interest of time because
Yes,
I want to
we want a couple of minutes for discussion.
Let me talk about this real quick and then I'll stop. And we can talk about the rest in the discussion. You had all also looked at annotation results. And they looked at tweets in context and out of context. So not tweets, Reddit posts. So they in one setting they gave the annotators only a post, and in the other setting they gave you the previous post. And you can see, so the blue is where the two conditions agreed. The reds are where there's significant differences. So if you have context, you classify, you annotate a lot of the tweets differently, and sometimes you get more hate, and sometimes you get less hate. But this is really concerning because normally what annotators get is just a single tweet or a single post. They don't have any context. Okay, I think I'm going to stop here and let people ask.
Thank you very much. I see people clap. So the discussion is open. You can also post your question in the chat, and Jania is going to moderate the chat. I will just start with a question that goes a bit beyond what you presented, in the way that the examples you showed us, they included some written character variations, but I think there were no emojis in those examples you showed us. What did you also look at phenomena like algo speech? So I mean, if you mask hate speech by using, for example, if you use a slur but you mask some of the characters by an asterisk, or also using emojis in a kind of way that could like mask hate as being ironic or something. So is there is that for the machine learner doesn't matter because it's just patterns, or do you see are there particular patterns that kind of mask hate or add to hate?
We haven't really looked into this, but in my experience, as long as the data set has some of those examples in there, the machine learner is actually pretty good at picking up on this. So if people spell the N-word differently, for example, then it does pick up on that. It's actually, sometimes that's more of a problem because I don't know if you're familiar with the how it works here in the US. So if you spell the N-word with an A at the end, that is actually reappropriated so by the African American community. So they're using it, or I don't know, let's say the bitch word. If I'm talking to my friend and call her bitch, I'm not insulting her. I'm using the term with pride, right? Or if I call myself a bitch. And the same thing is happening with the N-word in the African American community. So normally when it's spelled with an A at the end, it actually has a very positive meaning. If it's spelled with an ER at the end, then it has a very negative meaning. Unfortunately, my classifier does not pick up on that a lot of times. So we have to sensitize to that.
Olga Kellert?
Do you hear me? Yeah,
Mhm.
okay, perfect.
Yes.
Actually, yeah, a comment on this discussion. Wouldn't it then make sense to actually have a different groups of annotators? Basically, if you're annotate, let's say, Afro-American, then you include Afro-Americans as annotators, right? And or if you have jokes about women, that you have women as annotators or whatever, right? Or age, older people, and so on and so on. So because and then maybe the machine learner could learn that depending on the right.
Yep.
That was just a comment. I mean, like I think it goes along the lines that you presented, that we have to take care about the annotators, right? I mean, this is also a trend, right? Like Basile, for instance, they also look at how the background, social background, influences annotation, not only in the hate. I mean, there are a lot of sentiment analysis and many other annotations, right? So that's a general problem. So I'm actually interested in this implicity problem. Let's say, I think this is the one where we are humans, I think, still better than the machines, right? This is what you're suggesting, that we understand the implicit message, the machines not as bad, as good. And I'm wondering what one could do about that. I mean, I was thinking with large language models, I mean, there are data sets in natural language understanding, natural language inferencing, right? So I wonder how we could go about it if we have this hate speech problem or sentiment analysis, how to provide the machine learner actually more possibility to learn this implicit language, right? I mean, to maybe it's not enough just to give just pure the annotation, but we somehow give more context, give more data, NLU, NLI data, so that, for instance, I don't know, it could learn, even if it has just Twitter data, that bitch it has a similar meaning than some other similar word in a Reddit, or some other completely different data, or Shakespearean. What would Shakespeare say? But how would Shakespeare use instead of bitch, right? So basically, I mean, this is what learning is about. Otherwise, it's not learning, right? Otherwise, we can't talk about artificial intelligence at all if it's just mimicking, right? The what is there in the data set, and not really abstracting or generalizing, right? I mean, this is what we somehow want. So I wonder whether you have some ideas. Sorry for this long comment.
I'm not sure. I think I tend to start with the easy steps, and one of the easy steps is that currently we all use these lists of hate words to figure out what is implicit and what is explicit hate, and it turns out that most of these lists are really not good, because they were created semi-automatically, and there's a lot of very infrequent words in there that are clearly not hate. And I mean, the other problem is if you use these lists, then a lot of words are ambiguous. Yes, some of the occurrences of bitch are hate, some of them are not. And those distinguish between those two. So I think we need a solution for that problem first. How to get, and that would also help to get more implicit hate into the data sets. If we can find it better, then we can add more implicit hate. And that hopefully gives the machine learner a better chance of learning that. But then I think we also have to talk about changing the task definition. And we can't just look at a tweet in isolation. We have to look at a tweet as part of a conversation. But we also have to look at, there may not be one single answer, because different people look at the same tweet and some of them say, oh, this is hate speech, and some of them say it's not hate speech. So maybe there are different opinions, and we don't model one ground truth, we model the distribution in the society. But that, again, that necessitates a discussion about where does hate speech start? So what distribution do we need in order to say we have to take this down? And I mean, the governments don't help us in that. They make the law saying that you have to take it down, but they don't tell us what hate speech is. So I think that has to come out of the society, and we have to talk about what is hate speech and what is not.
Mm-hmm. There are questions in the chat. Maybe we can move on to that, Jenya.
Yeah, one is a clarification question from Svetlana asking if you could please give an example when it is hate speech for non-African Americans, but it is not hate speech for African Americans and vice versa. Thank you.
So I think the N-word is one of the examples. If an African American uses the N-word, then they're talking about themselves, and they're not using it as hate speech. And they sometimes, and it's not necessarily African Americans versus white people. Sometimes white people speak African American English. And in that case, they would also use the N-word in that sense. But I mean, if you're from Europe, you know that the French people swear a lot more than other nationalities do, and for them it doesn't mean anything. So it's the same thing. In African American English, you can say things that are super non-polite in white English. So that there's differences there. I don't want to say more because I'm not exactly an expert in that.
Thank you. And then there's also a message from Mary, who says, "Hi, Sandra. Thank you very much for the insightful talk. I'm Mary, a postdoctoral researcher in Hong Kong. I have two questions. I'm using Roberta for a sentiment analysis of Twitter data. I can find F1 accuracy and precision of Roberta models on the pre-trained data. Can I calculate F1 accuracy and precision on my own data set?" And then she also has a second question. Should I pause while you?
Yeah, maybe both.
And the second question is it possible to use LLMs such as ChatGPT-4 to detect hate speech if I give enough and suitable prompts? Thank you very much.
I don't know how to answer those. Let me see. So yes, you should be able to test on your data sets, and then you should be able to calculate the F-scores on your data sets if you have the correct answers. If you don't have correct answers, then no. Then you have to sit down and annotate at least some of them so that you can calculate how well it works. For the second one, yes, I'm sure my colleagues have been using ChatGPT to detect hate speech. I'm trying to stay away from this kind of research because I don't think it's research, it's playing, because it's not replicable. ChatGPT today will look potentially completely different from ChatGPT next week. And I have no idea what's going on there, and I can't replicate it, and so I'm not doing that.
Let's take a final one.
Yeah, final answer. Question, sorry, by Sarah Smale.
Hello everyone, can you hear me?
Yes.
Perfect. My name is Sarah Smile. I'm actually a student, a PhD student at the University of Limerick in Ireland. And I am working on an article about hate speech detection in tweets, mainly in Twitter. And I'm doing that I'm analyzing the tweets from an ideological standpoint. So my question is, how do ideological alignment influence the perception and detection of hate speech on social media platforms? And how can we avoid them?
Good question. I don't know. I'm sure there is an influence. I'm not sure if anyone has looked into that. And I'm also not sure if you can get that kind of data.
Mm-hmm. Now, my data actually are in 3 different languages. I have like approximately 4,000 tweets, and they are tweets from Northern Africa.
Mm-hmm.
So there is a lot of ideological issues in there, a lot of racism in it. So I was like about how to avoid such like ideological issues and how to identify such issues from these tweets.
You will probably have to go down, get down and get your hands dirty and annotate. I don't know what else to say. You can, I mean, there are data sets, at least for specific languages. I know that there's a couple for Arabic. I don't know for what other languages. But yeah, hate in different languages is very different. And I think we have to do the groundwork on that.
All right. Thank you.
Thank you very much. I think time is up and we can encourage, I think if there are further questions, maybe you can address Sandra by email. Thank you very much again, Sandra.
Thank you.
And we are closing the session now, but Yannis, can you
the next
give us
talk,
information about the next talk?
The next talk will be in 4 weeks on April 25 by Christoph Borschke from Luxembourg, who is in computational social linguistics. See you hopefully there. Thank you so much.